Hi, Tony from Hurricane Wind Power here. What I have is a quick video for one of our installers today to demonstrate a system to allow them to do some things that are a little bit out of the ordinary, and what we have here is a workaround. So we're going to share this in case any of you are having similar issues with something that you're trying to do. So in this case, there's no wind turbine involved. This is a solar install. They are using higher voltage panels. They're using a 12 volt system. So what we have done is we've emulated a higher voltage, and you can see we're at 54 volts. And we have this coming into an MMPT controller, which allows for charging of a 12 volt system. And we only have about 150 watts going in here. But what we have is this, this wouldn't be very efficient at all if we just hooked 70 watts of solar to a battery and then hooked up a dump load. It would be terrible. So this person also wants hot water. So what we have here is a SSR relay that is on a big heat sink that we sell. And the purpose is to give this individual constant hot water, and there should be a thermostat involved in this. So I mean, once the water is heated up to the predetermined temperature, this can flip on and off, but we're still not going to be feeding power. There's no diversion load needed, because when the charge control reaches its set points, a solar panel doesn't have to be always on. So what I've said here, and it can be programmed however we want to with this little controller. There's a little box that goes over it. But what I've done is I've taken in the upper limits on this controller from 13.8 down to 13.5 for this to open and close this relay and allow some power to go over here to give this gentleman some hot water. So you can see this operating here, open here when the light goes on at 13.8. It dumps, it goes down to 13.5, and it closes, and there you go. So what we have here, if you're interested in following this circuit and what's going on with it, is we're emulating our power in from the solar panel. Then these two go to the battery. This is terrible. This looks like this is obviously not how we would do something, but when you're just putting up for something for testing purposes, it's not, we're not going to make the wires nice and neat. On these two, these are positive and negatives for this control module here and here to read the power and the voltage of the battery. What we have here is the negative side. This is the negative side of the hot water heating element, and this is the positive side of the circuit. The current flows through here, and this is opened and closed, and it goes through there, completing the circuit and heating the water. So if we turn this little guy on here, this water is at 169, 170 degrees, and it keeps on going up.